We're back with 3D Printer Fix-Up Part 2. We're going to continue our work on our Kingroon KLP1. Hello everyone, Chris here. Yes, we're continuing on with our 3D Printer Fix-Up where we're working on the Kingroon KLP1. In the previous video, we got the hardware swapped out for the main board. We went with a BTT Manta M4P. That board's going to have more than enough features to operate this 3D printer. We were also able to flash our SD card with Linux and get Klipper up and running. We can log into it, but now the fun begins where we start to configure our Printer.cfg file. And that can be a pretty tricky process if you don't have the original Printer.cfg and you don't know a lot about the machine you're configuring it on. We do have an example configuration for the Manta board, but it doesn't know anything about the hardware we installed it on, so that's where we come in. This video is going to be all about updating that Printer.cfg file. We'll work through it line by line. We're going to have to figure out a lot of different errors, do a lot of troubleshooting, but this should give you a great idea of how to do this kind of thing if you're doing it on your 3D printer project. So let's get into the screen share. We've got a lot to do. This will extend into multiple videos, but we should at least be able to get the printer up and running and moving around today. So let's get to it. Just a quick recap from the last video. We don't have a lot installed on this board. We only have 3 drivers, A, B, and Z, or X, Y, and Z, if you want to think of it that way, because it is Core XY. We only have the bed hooked up power-wise and the PSU. The rest of it is on the tool head that we'll address later. We do have a filament sensor in there as well. So we can only configure certain things, but again, it's going to give us a great start. We'll start here, but remember we've already compiled, done our make menu config, and loaded that file on the mainboard MCU. You saw that in the last video, so it already knows about our Klipper configuration that we've created. They're on the same versions. So we're good there, but you see when we load up mainsail, this is the initial error, and if we just go to machine and then look in system, we'll just look in this printer.cfg. They have a bare bones CFG file, and this is where we're going to start. We're actually not going to use this one. We're going to grab the generic Manta config file that the Klipper project actually offers. So we'll just close this, and we're going to go up here to root and go to config examples, and we're going to find that Manta example. I'll just switch this to all so we can scroll through them. BTT Manta M4P. We're going to start with this one. So I'm just going to grab this one, go in, Control A, and then Control C to copy it. And I'm just going to paste it over that default config file. You can do it however you wish if you want to make a copy. Remember, if you're flashing, when you're in Make Menu Config, these are the parameters that you set in there for this board. So we'll close this, come back up to the top, go back to the regular config file, printer.cfg. I'm going to select all again, Control A and Control V to paste it. And we'll just start here. We're going to bring up a whole new set of errors, but we'll worry about that after we've saved and it's restarted. We will have to grab our MCU again. We'll do that next. While Klipper is thinking about what it's doing back there, let's go ahead and get our MCU. You can do that by doing an ls. You want /dev /serial /by-id. If it comes up with nothing, that means you have a communication problem, but this is the MCU address of our board. So we'll copy that. You can just select it if you're using PuTTY, and then we'll go back to printer.cfg. We'll open that up, scroll down, there should be an MCU slot. It might be close to what you already have because it knows about this board, but we're just going to do it side by side here so you can see serial, and I'll paste it in, and then we'll just add the fully qualified location. So /dev /serial /by-id. So it knows where that device is. But now you can see side by side the differences because it is a different kind of chip. They've used a different number. So not all of them are going to be the same. So you can either delete this top one or comment it out. And again, there's going to be a lot of this today. We're going to save and restart. Now this time we're already looking better because we can see that it sees that MCU because we have that parameter set in the file. But we've hit our first error, ADC out of range. That usually means there's a thermistor somewhere that it can't get a hold of. And that is the first thing that it's going to do, is try to get temp readings. And if it can't get the correct ones, it's going to sense danger. Something's not right. Maybe it's over temp, whatever it might be. You have to know what the thermistors are doing in case, something bad happens, it might burn down. So it's going to check for all of that. We do have a bed thermistor, but we don't have a hot end thermistor right now. So we'll correct that next. So again, Printer.cfg, we're just going to go in. All of your settings should be under extruder. You can see there the sensor type, all of that. We will need this at some point, but for now, I'm going to put comments in front of all of these lines. Just put a pound sign in front of all of them, and then save and restart. So now we've already got rid of our first round of errors. It doesn't see that thermistor anymore, so it's not going to be able to heat that heater, right? So you're not going to have any issues. So if we go to dashboard from here, we have a set of missing configs. We'll fix that next. But you can see it is reading the bed correctly. So 21, that should be really close to what it is. So we can test that, but at least we know our bed thermistor setting, the default one that was in that Manta config, is going to be relatively close. Now, you always want to check to make sure those are close, but if it's reading room temperature, that's probably a good place to start. Then you want to take actual temperatures if you don't know what type of thermistor that is. That's always important. But now on to these errors. So this error, what it's calling for are things that are missing in the configuration, but a lot of times the configuration includes things in your mainsail.cfg that aren't in your Printer.cfg. Those files don't know about each other. You have to include them. So you want to include your mainsail.cfg in your Printer.cfg so they can find things like these macros that it's calling about. It's very easy to fix these. We'll just go to Machine, go to Printer.cfg, and then I like to include my include statements at the very top. You just put them in brackets. We're just going to do include mainsail.cfg. And we'll save and restart. When the restart is done, you can see that error is gone because now it can get into mainsail.cfg and find those macro files that it was missing. So we're already making good progress. Next up, we're just going to hit the highlights here, the most important on down, but Printer.cfg again. We're going to scroll down a bit. First thing you want to tackle after your MCU is printer. So kinematics, it's going to default on most of these to Cartesian. We have a core XY. So we're just going to change Cartesian to core XY. I'm going to leave these default. We will want to change these up before we put this thing into commission. It'll go a lot faster than these, but it's a good place to start. Also, EXP1 and 2 for the Manta, you can leave these here. We're not going to address that because we don't have a screen, but these are the default locations. It's good if you want to use it down the road. Now, driver configuration is what we'll hit next, but I do strongly suggest that anytime you make any kind of change, go ahead and save and restart to make sure it's okay. If it comes back clean, there's no ugly errors, you should be good to go ahead and continue your configuration. So we're good there, no errors. Let's head back into Printer.cfg. We need to talk about motors. So the KLP1 does assume that you're using sensorless homing. It has no end stops for X and Y. So we have to configure that. Now I have a whole video on sensorless homing for Klipper. You're going to want to take a look at that. That's in the description, but let's just knock it out for this build. First thing we have to do is look at our end stop pins. When you're using sensorless homing, you don't have a physical pin like a switch would be hooked to. You're using it internal in UART. So it gets that sensor, it gets the information from the diag pin, sends it over so that it knows it's an end stop. So you have to configure that. So you just update the end stop pin. Remember these though, because we're going to have to use those as the diag pin when we configure the driver. So PC0, PC1. They do have the caret in front of them. That means they have a pull-up resistor assigned to them. We probably don't need that. Just note it in your configuration. You might have to use it later. But for now, we're just going to type this over. We do have the TMC 2226, but they're pretty much the same as a 2209 in a different package. And as far as I know, Klipper doesn't directly support that name, so we're going to call them 2209s. So TMC 2209 underscore stepper underscore X, and then a colon virtual underscore and stop. And we're going to do the same thing for Y. So we'll just copy this. And then go down to the Y section and we'll paste it. And then update it to Y. Again, it's always a good idea to save and exit, save and restart before you move on, because you're going to see the errors and you're going to know why they've been caused. So let's just do it, see what happens. We restart, it comes up. Unknown pin chip name, 2209. It's because we haven't configured it yet. That's what we're going to do now. Printer.cfg. Scroll down. There's already a section for drivers down here, but it's commented out. They do give you a configuration for 2209 and 2130. So UART drivers, SPI drivers. We have the 2209 or the 2226, same type of chip. So we're going to take the comments off of X, Y, and Z for now. We'll do the toolboard stuff later for the extruder. Here, to use sensorless homing, we need a diag pin. That's going to be the in-stop pin we saw before. So for X, that was PC0. And then for Y, that was PC1. Now we also need to set the stall guard threshold. That's the feature that it uses to do the sensorless homing for each of the drivers. So we need to add driver underscore in caps SGTHRS, stall guard threshold, and then a colon. And for a 2209, different drivers act differently. 2209, 255 is the most sensitive, 0 is the least. I like to start around 100. So we're going to set this to 100 for now. And we're going to do the same thing down here for Y. Driver underscore SGTHRS colon, and we'll set it to 100. We will no doubt have to tune this in, but we have to start someplace. Now for Z, we're not interested in a diag pin. We can add some other things to this configuration, but I'm just going to put that comment back on here for now, and we'll save and restart, make sure everything's working correctly. So the error went away. It knows about the drivers now. It's okay with the configuration. So we should be good to go ahead and test a movement. Now, I have no doubt that it's going to crash into the side because that sensorless homing setting, or not move at all. But because that setting isn't correct, but let's just go ahead and try it. So we're just going to try an X and Y home here in the dashboard, because you can't move unless you do some tricky things. You can't move unless you've homed an axis. It's a good sign if this is enabled. It knows that it has the motor in the configuration. So I'm just going to hit X and let's see what the printer does. So we're just going to hit the Home X button to see what happens. Now you notice the print head moved all the way to the back of the machine in the Y direction. So we definitely have something off. But the sensorless homing worked. It did stop, at least when it collided. Let's go ahead and do Y. That's the X direction, also in the opposite direction. But again, sensorless homing worked. So something worked correctly. Back to Printer.cfg so I can show you why this happened. So in the stepper section, this is where you're going to control things like this. You will notice the dir pin. So PA14, that's not really important, but come down to dir pin for Y, it's got an exclamation point in front of it. That means it swaps the logic. So if it's rotating one way, you put an exclamation point in front of it, that means it's going to rotate the opposite direction. You want those the same in a Core XY configuration. Now, wiring can change things. You can wire stepper motors a certain way, depending on how you have the stator that will make it turn one way or the other, like flipping the plug over, basically is what you're doing. But from this configuration, this is the default. We just want to take the exclamation point off of one of these. They need to match. So they either need to be both on or both off. And I'll show you what that's going to do. Save and restart. And I'm just going to move the print head back to the center here by hand. But then we're going to go ahead and hit X again, X home. So we're moving X, but it's the opposite direction that I would want to go in. hit Y home, it's moving Y now, opposite direction. So we're good on the axes, but I would like them to move in the opposite. So an easy fix, back to Printer.cfg, we're just going to go ahead and put the exclamation point on both. And we'll save and restart. Now if we do home X, it's going to the left. That's how I would like it. And then home Y, we're coming to the front. So now 0, 0 is in that front left corner. It's much easier to configure that way, in my opinion. So we've got X and Y going, and since this homing is working. Now, unfortunately, we can't tackle Z on our KLP1 yet because we have to deal with that tool board. That's going to be a whole video for sure, but you notice we have a probe here. They use probing for homing, so that's going to have to be attached before we can call it. So let's not tackle that, but there's a few other things that we can do really quick. First off, the bed is reading temperature. I'm just going to set it to 60 to see if it does heat up. See if the bed connection is working, the power is working. If the temperature starts to rise, then I'll know at least we've got that configured. And it looks like it's heating, so that's a good test. Done with that one. And we do have a filament sensor. Remember I showed you we plugged it into that E0 in-stop. That's usually where they put them. But if you go to machine, Printer.cfg, this example config, they do call it out. So we're going to go ahead and configure that. All we have to do is take the comments off of those lines. It's already got that pin configured. Remember, you can always verify that in the GitHub. You have a default configuration, the same one we're working from. If you get lost, and you have your pin out. E0, come over here, PC15, we're good. So that's one feature we can get out of the way. And you can see we do have some errors over here. That has to do with retract distance, senseless homing. We'll clean all of that up. But we can at least test Z to make sure it's turning the right direction without the probe. We're just going to have to be quick on the stop. So I'm just going to disable all the motors. Probably not the best idea to do this while the machine's plugged in. You don't want to feedback motors if you don't have to, but there's a lot wrong with this machine already. But I'm just going to slide this down to about mid-grade there, and then go back. I'm just going to hit that Z home button to see what it does. So we'll just hit Z home. And what is this? We have an error. Short to supply A. So what it's trying to tell us is we have an issue with the wires for our Z motor. It's actually shorted it out with the stators. And there's a couple of different ways that motors can be wired, and you have a 50-50 shot of getting it correct, but you can always test to see if they are correct. So it might not be a bad topic for this video. Remember, I told you in the last video I had to build a new cable for that Z motor because my stock one, the one that came with the KLP1, wasn't long enough. So for the test, I'm going to go ahead and shut the machine down. I'm going to come up here to power, just do shutdown. So again, just some extra troubleshooting information if you have to do stuff like this. But our Z motor's right here. Underneath it, it's belted. But it's really easy to turn this lead screw to move Z. So you're going to need that to test. Now we have our stock cable. Remember, on motors, you have like a 6-pin on a regular stepper, on a NEMA 17 anyway. You have a 6-pin, and then on our board, we have this 4-pin JST. This should be correct for the stock board. So let's just plug it in real quick. And I promise, since I know this printer might actually work someday now, I'll dust the printer for the next video. But anyway, here's the stock cable. So I'm just going to use this jumper wire here. And I'm going to just short out 2 of the pins. Remember, the power is not on, but I'm going to short out just any 2, just match them up. And then test that motor again. It's really hard to turn now. So we've locked up one of the stators. We know those pins go together. So those are the outer 2 pins. By all rights, if we do it to these 2 pins, same results. It's the other stator. Yep, hard to turn. Now, what about our new cable? Our old cable is set up matched, 2 and 2. If we take a look at the other end, so you can see that our stock cable is straight through. it's 1, 2, 3, 4, 1, 2, 3, 4 on both sides. Remember, there's multiple kinds of motors, but this works for the motor that's on the KLP1. The cable that I threw together in the last video, of course I didn't test it. You can see that both sides are different. So this is probably for a different type of stepper. But I have blue, red, green, black, black, red, green, blue. So an easy enough fix. We have a swapped set for the stators on this. We'll just make it straight through like this other cable. But the test that I showed you is still valid. That's how you figure out what type of motor you're dealing with. So let's just swap the cable. I just used an O-ring pick to push down the pins, but now we have a straight through cable just like the stock one. Black, green, red, blue, black, green, red, blue. And now that we have our new cable on and swapped around correctly, let's just go ahead and repeat the test. We have those two on the side shorted out. It's pretty hard to turn. We're going to flop the jumper over the other two. It's pretty hard to turn. We should be good. If you remove it, it's easy to turn again. Now we can plug it back in, power up, and then go back to the mainsail and test it. So we're powered up again. Mainsail and clipper, all that has booted. I want to test. I'm just going to go ahead and hit that Z home button again. So Z did move, but not very far, because it can't get a status of that end stop. But the motor is turning correctly. It can move the bed around. So it's a valid test. You can see I did it a couple of times. Z still triggered after retract. It was trying to retract before it could read that end stop, but it couldn't move any further because it can't get a read on that. So it's a safety measure, but we know the motor works, and that was the whole point. So we have a great start here, but we can't move forward without that tool board. And that's going to take a whole video to set up because we don't know much about it, and we have to configure a file for it that's going to match our settings. So we've got a lot of stuff moving. Sensorless homing's working. All the motors seem to work. We did get our filament sensor and our bed works, but we have a long way to go. So that's it. We got a high percentage of our Printer.cfg file done today. We're up and moving around at least, but we have a lot more work to do. We're going to get into that tool head and configuring it in the next video. And thank you to a lot of the folks in the comments. I had thought this printer supported the tool head on CAN bus because of the connector that was used on the printer, but it's actually USB. So that's going to save us a little bit of time in the next video. But don't worry, those that are used to using CAN bus or want to know more about it, that will be in future videos down the road. So hopefully you found this one helpful. That's it for today, and I'll see you really soon on the next one.